Walaikum salam.
Is it audible? My sound is clear.
Yeah.
This was the last thing we were discussing, that if we add a limited amount of sodium hydroxide or we add a limited amount of aqueous ammonia, because OH or ammonia both are the bases, so they tend to accept proton. So they will accept proton from aqua complex. Aqua complex means a complex which contains water molecule. So at proton is lost, so it will like become, when the two protons are lost, so this will become copper 2 hydroxide and plus 6.6 H2 4 H2O, 4 water molecules are also there. And this will give a blue precipitate. Same thing for chromium, because chromium valency is plus 3. So 3, if when we compare the tendency, which is more alkaline here, so chromium tend to lose 3 protons. So this complex in turn, first reaction is acid-base reaction. So OH is accepting proton and this one is donating, so it is acting like an acid. So chromium complex is more acidic because it tend to lose 3 proton as compared to that of copper, which tend to lose only 2 protons. Same way, if we add an aqueous ammonia, so a loss of proton will occur. It's easy to identify the valency, the charge on the complex will decide how many proton it will lose. Because they're forming a precipitate, so to form a precipitate, it should be neutral. So if zinc is plus 2, that's why it is losing 2 protons. Iron is plus 3, it is losing 3. And this process can happen stepwise, removing 1 proton at a time. And like first, like chromium is their example, first chromium will lose its 1 electron, then it will lose its second, and then so on, it will lose its third and form the complex, which is having no charge. If there is no charge on the complex, then it will call, it is known as the precipitate. You have to learn the colors for each precipitate. Same thing, if we add an excess of sodium hydroxide, so what happened with excess of sodium hydroxide, chromium and zinc hydroxide dissolve. So why this dissolving occur? We call they are amphoteric, because if base is reacting with base, because actually it is chromium 3 hydroxide. So chromium 3 hydroxide, generally hydroxides are alkali, but when it reacted with more sodium hydroxide, so it means the reaction of hydroxide with hydroxide. This is losing proton and sodium hydroxide or hydroxide ion is gaining proton. So this chromium hydroxide is acting like an acid. So we call that as amphoteric, because generally hydroxides are alkali, but in this reaction it is acting like an acid. That's why we call this hydroxide as amphoteric. So chromium 3 hydroxide is there. If we add excess of sodium hydroxide, further 3, it will lose proton. So it will become minus 3 charge. Why? Because chromium is plus 3 and each hydroxide is minus 1. So 6 hydroxide will be minus 6. That's why minus 3. And whenever there's a charge on the complex, they will be aqueous or dissolved. So that's why we observe a precipitate dissolve. With chromium, it will give a green solution. With zinc, it gives colorless solution. Why? Because the zinc, the d orbital is complete. If a d orbital is complete or d orbital is, for zinc, d orbital is empty. For scandium, d orbital is complete. So we can identify that it should not have a color. That's why it is forming a colorless solution. Is it clear? So adding a limited amount of sodium hydroxide or aqueous ammonia and adding an excess of sodium hydroxide. These are the results. Any doubt in this?
No.
And I already shared this, so you can copy from that part. I'll quickly go through. This part is mainly related to memorization. So with excess of aqueous ammonia, there's a ligand exchange reaction occur with zinc, copper, and nickel. Zinc, copper, nickel, and chromium, and their precipitate dissolve. So ligand NH3 or H2O, they have the similar size and uncharged. So ligand exchange occur without changing coordination number for cobalt and chromium. So example, you have chromium 3 hydroxide, which is formed first when you add a small amount of aqueous ammonia. if you add an excess of aqueous ammonia, so what happened? A ligand exchange means all these molecules are replaced by ammonia, and you can see here there's a charge on the complex. So there's a charge on complex. It shows that the precipitate will dissolve and it will form either a color or a colorless solution. Same thing for copper. It will form a deep blue or a royal or a inky blue solution because the precipitate dissolve. A ligand exchange occur. It does not make difference. For example, here you can see the first one. In the first one, you can see with chromium, when three hydroxide and three water molecules are there, all of them are replaced by ammonia. But when there's a copper, not all of them are replaced, because when the element is having a small charge, it cannot attract these ligands strongly. That's why the replacement, all are not replaced, only few of them are replaced. So out of these four water molecules, two of the water molecules are replaced and two hydroxides are replaced. But the coordination number does not change. Here, the first coordination number 2 plus 4, 6. The second coordination number is 4 plus 2, 6 as well. Is it clear? So with chromium, it will form purple solution. With nickel, it will form a blue solution. Zinc, it will form a colorless solution. And copper, it will also form a deep blue solution. The ligand exchange reaction with chlorine or chloride ion. So if we add a higher concentration of the chloride ion from hydrochloric acid or sodium chloride, we have a ligand substitution reaction. But what happened, because chloride ions are larger in size and they have charge as well, so the coordination number of the metal will also change. So for example, if a solid copper chloride or any other metal is dissolved in water, it will form an aqueous or aqua complex, means the water molecules are there, not the chloride complex. Because what happened basically, if I say I have copper chloride solution, a copper chloride solid, when I add this copper chloride to water, the copper ions will dissociate, means it will dissociate into copper ion and two chloride ions. So these copper ions are attracted by water molecule, and chloride ions are also attracted towards water molecule. So the complex which is formed is between the metal ion and the water molecule. So this will be a complex. If in this complex we add a concentrated hydrochloric acid, too much hydrochloric acid, so what happens? Chloride ion will replace the water molecule and it will form CuCl4. Coordination number also change. Here the coordination number was 6, mean number of the dative bond, but with copper the coordination number is 4, because copper is larger in size and there is a charge on it, so the coordination number will decrease. Is it clear? Any doubt in this?
No.
Then the stability of the complex, the substitution of monodentate. Mono means one and dent is for the teeth. So if a ligand can form a bond from one side, we call monodentate. If it can form a bond with two sides, we call bidentate. And multi or polydentate means it can form bonds from different or more than two sides. So the substitution of monodentate with bidentate or with multidentate leads to more stable complex. Why? Because this effect can be explained in terms of entropy. How? If you can see here, the number of the molecules, reactant side, you have 2 molecules, but the product side you have 6 plus 1, 7 molecules. So as the number of the particle increases, it means the entropy will increase, means it will have greater or more disorder. So that's why, as like if you have EDTA, EDTA is a polydentate, means it can form approximately it can form 4 dative bonds. So, and you have 6 water molecules. So this EDTA will replace the water molecule. So Cu EDTA, the charge on EDTA is -4 and copper is +2. That's why overall charge on the complex is -2. Plus 6 water molecules are released. So the copper complex sign has changed from having a monodentate ligands to a multidentate or a polydentate. And this reaction is an increase in entropy because the particle number will change from 2 to 7, so which create more disorder. The stability of EDTA complex has many applications. It can be added to river to remove the poisonous heavy metal ion, as the EDTA complex are not toxic, and it is in many shampoos to remove the calcium ion present in a hard water, which help in lathering. Is it clear? So EDTA, if we add EDTA, it can easily form a complex with a metal ion, and it has many applications. If the complex, if when it form a complex might, if there's no charge on the complex, then it will form a precipitate which can be filtered to remove from the solution. Ethane 1,2-diamine, which is also known as a bidentate. Why we call bidentate? Bi means 2. So you can see here, this is one molecule of ethane 1,2-diamine. First example, there was a complex of a cobalt with ammonia, but when we add ethane 1,2-diamine, so the coordination number will also, the number of the dative bond it is forming, the coordination number is 6, because this is one molecule of ethane 1,2-diamine. The term coordination number means number of dative bond. This is the second molecule, and this one is a third molecule. But what happened? Each molecule can form 2 dative bonds. This is 1, 2, 3, 4, 5, 6. So even a bidentate will lead in increase in entropy. Why the entropy will increase? Because you can see the number of the particle 1 and 3. So there are 4, but this is 1 and this one is 6. So there are 7. So this reaction also leads to increase in entropy, or entropy of a system is positive. And here the delta H is equals to the enthalpy change is equals to enthalpy of surrounding is 0, as the number of dative bond and the type of bond are same for, so they require the same amount of energy, because basically the dative bond was between a cobalt and the lone pair of nitrogen and ammonia. And same thing when it formed a bond with ethane 1,2-diamine, it's also are forming a bond with lone pair of ammonia. So bond breaking energy and bond forming energy will be same. So energy change will be 0, or entropy of a system will be 0, because entropy of surrounding will be 0. Entropy of surrounding is delta H by T. And what is delta H? Delta H is change in energy. So there is no change in energy, because same type of bonds break and same type. Like if I need 100 joule of energy and new bonds are formed, 100 joule of energy released. So overall energy change will be 0. So entropy of a surrounding is 0. The total entropy is depending on only entropy of the system, and entropy of system increases as the number of the particle increase. So it will form a more stable complex. Is it clear?
Yeah.
And same thing, we can also add this 1,2-ethane 1,2-diamine for deprotonate the complex or remove the proton. Similar to that, like ammonia we used to do. So if we have a complex of aluminum, we add this ethane 1,2-diamine. So it will accept 3 proton. It will form a complex, and the hydrogen, because it accepts proton. So it should be balance equation. So if we have two molecules, each molecule is losing each molecule is losing 3. So two molecules will lose 6. So small molecules such as N2 and H2 cannot act as a bidentate even though they have lone pair. But the thing is that, like example, same thing for water. Water cannot be a bidentate. Why it cannot be a bidentate? Water is always a monodentate because the lone pairs are together and very close to each other. So these lone pair by themselves, they have repulsion. So they're not able to form a dative bond with a metal. So some common ligands like uh, ethanoate or carboxylate ion, which is C double bonded with O and C double bonded with O. This is also a bidentate. Why? Because it can form two dative bonds. So if you have a complex, you add a bidentate ligand. If a ligand exchange occur, then the coordination number here is same because it's a bidentate. So it is forming basically a 6 dative bond. Each molecule of a ligand is forming 2 bonds. This is one. This is a second ligand, and this one is a third. Then the partial substitution of ethane dioate ions may occur when an aqueous solution containing ethane dioate ion is added to a solution of copper 2 ion. In this reaction, 4 water molecules are replaced by new complex. So there are 6 water molecules, out of 6, 4 are replaced by C2 and O4. But 2 molecules will replace, molecules will be 2. Why? Because it's a bidentate ligand, so it will replace, each molecule will replace 2 water molecules. That's why total 4 molecules are replaced. The bond angle, depending on the number of the dative bond, if there are 6 dative bond, the bond angle will be 94 dative bond, tetrahedral 109.5, and if 2 dative bond, the bond angle will be 180 degrees. Then using a silver nitrate to work out the formula for chloride containing a complex. So how we can identify how many chloride ions are there in the complex? So simple way to identify. So sometimes the compound contain a complex which may have a chloride and acting as a ligand inside a complex. So chloride ions outside the complex are attracted towards silver ion and it will form a silver chloride or it will give a white precipitate with a free chloride ion outside the complex. So example, if we have cobalt which is containing 6 ammonia attached to it and 3 chlorides are attached to it. React on 1 and 3 mole ratio with silver nitrate. Why 1 to 3? Because if you have cobalt, 3 chloride, you add silver nitrate. But how you will identify the ratio? So for this ratio, we'll take equal concentration of cobalt chloride and silver nitrate. So concentration of cobalt chloride and concentration of silver nitrate should be same. Then we will take the volume. Like if I take 10 cm cube of cobalt 3 chloride, then I will first add silver nitrate 5 cm cube, then further 5 cm cube. We will add until the height of the precipitate or the size of the precipitate will not change. So this is the volume of silver nitrate added, and this one is a precipitate height. So once the height is constant, it shows that the precipitate are not forming, or this is a point actually where the reaction occur. So you can compare the ratio of the volume. So if originally I used 10 cm cube of cobalt chloride and I need 30 cm cube of silver nitrate, so I can simply say the mole ratio because we have the same concentration. When we have the same concentration, the ratio of the volume will decide the ratio of the moles. So 1:3 is the mole ratio. And using this, we can identify that this complex contains 3 molecules of 3 moles of chloride ion. Is it clear?
Yeah.
This is the way how we work out the formula for complex. Then you have to learn this whole table. If you have copper chloride complex, this is a green solution. If you add water, it will become blue solution. Here metal can be, any metal is there. If you add, normally these are the complexes. If metal with copper, blue solution, iron 2, green solution, nickel, green solution, manganese, very pale pink solution, and zinc is colorless. If you add few drops of aqueous ammonia or sodium hydroxide, it will form, okay, acid-base reaction will occur and it will form precipitate. If you add in excess nickel and zinc and copper, these precipitate dissolve and they will form a colored solution. If you add oxidizing agent, so if iron 3 or precipitate are there, it will form a brown precipitate. It will turn from, uh, originally it was here green precipitate, it will turn to brown precipitate. And because here it is iron 2, but when it is oxidized, it becomes same thing for manganese. Here in this example, it's MnS plus 2, but here MnS plus 2. So basically, we add air or any oxidizing agent such as hydrogen peroxide. We have to learn this table, memorize these things. And the iron summary overall. So if we have a complex of chromium or iron, complex of chromium is green, complex of iron 3 is yellow. If we add aqueous ammonia or sodium hydroxide, it will form a green precipitate with chromium and it will form brown precipitate with iron 3. If we add access, the chromium precipitate, there is a ligand exchange. With iron, there is no change. If we add an excess of sodium hydroxide, then again there is an acid-base reaction, so which shows that the chromium precipitates are, or chromium hydroxide is amphoteric in nature, that's why the reaction occurs. If we add an oxidizing agent, it will form chromatine. If we add an acid, it will form dichromatine. If we add an alkaline, it will form chromatine. Chromatines are yellow in color, dichromatides are orange in color. So this is a total summary for plus 3 ions. This was a summary for plus 2 and this is for plus 3. So you have to memorize these tests for group the complex ions of transition element.